Hey guys, this is Unit 14.2, and it's just notes over reflections on a coordinate plane. So, the first one we're going to talk about is reflecting over the x-axis. And when you think of reflections, I want you to think of a mirror. And, when you look at a mirror, the same thing looks back at you. All right, so these shapes are going to mirror each other across a line. So I have my x-axis. I'm going to start by finding my x-axis and highlighting it. All right, and then once I've done that, I have on this cheat sheet the reflection or flip is what it's called. These little tidbits that can help you. So if I have AB and I'm reflecting across the x-axis, what is going to change is the y value. Quite interesting, right? So the x-axis is what we're flipping it across, but the change is the y-axis. So basically what it means is you take the y value and you change the sign for it. So instead of x and y, we're going to call these a and b. So the x value does not change at all. The y value will change sign. So if it started off positive, it'll end up at negative. All right. So we are going to flip this over. So for a, the x value will not change at all. It's going to be negative 3. Our y value is 4, so we are now going to make it negative 4. So let's see what happened. Negative 3, negative 4. Our a is now over here. Now that is a prime. We talked about that last time, how the image, the pre-image, is just the normal point and then the prime point. Okay, and then b prime, the x is going to stay the same because we're going over the x-axis. And the b is going to change sign. So it's positive, it will become negative. If it was negative, it would have become positive. Alright, and so now our b is going to be here. So notice what's happening. Another way you can look at this is think, okay, here's my line. It's 1, 2, 3, 4 away. So now it's going to be 1, 2, 3, 4 the other way. This one is 1 away, 1 up, now it's 1 down. So C is 1 up, now it's 1 down. Let's see if that follows the pattern that we had, our C prime. Now it is 0, negative 1. What changed? This stayed the same, and this changed signs. Perfect. Right, so that's how you reflect over the x-axis. So you'll have to pause this. I already wrote in the points so you can get those written down. Now it says to reflect over the y-axis. Ooh, this one's weird. So it runs right through that triangle. But it's okay because we're going to look at these points individually. So my E prime is going to, when it flipped over the y-axis, what happened last time? Our x didn't change, but our y changed. Well, the opposite is going to happen here. Since it flips over the y-axis, our y value will stay the same, but our x value will change signs. So it's going to end up being a positive 1. So this is negative, so it turns to positive 3. So it doesn't change. So our E prime is now there. E prime. So I accidentally mixed my F and my G. So I'm going to switch these. My F is negative 1, 5. My G is 3, 2. There we go. So my E is going to be same idea with the E on the X and Y value or axis. It's 1 to the left. Now it's going to be 1 to the right. So it's a positive 1, 3. The change was to change the sign of the x value. Everything else stays the same. Okay, for F, it's at negative 1, 5. We're going to change the sign of the x value, leave the y value. There's my f prime. And then for g prime, change the sign of the x value. The y value stays the same. And now we have the shape reflected across the y-axis. On to the next. This one gets a little bit tricky. So I have my A, my B, my C. They're already written down. And I've got this line, y equals x. And if you graph that line, it's just going to simply be a diagonal line. Arrows on that. And we want to now reflect it. So there is like a cheat to it. I'm going to show you two ways, and it's whatever you like to do. It's the best. It's, you know, it doesn't matter. There's two ways to do it. X and Y switches to YX. So basically you have your A and your B, and then you just flip-flop them, but you don't change the signs. So let me show you. With A, the A prime would simply be 4, -3. Another way you can do this is to count from A diagonally and figure out how far it is from this line. So if you like this better, you can also do this. Start here and you count 1 diagonal, 2 diagonal, 3.5 diagonals. So starting from here, 1, 2, 1 half, 1.5, 2.5, 3.5. Now we have our A prime. So you either just flip the images, or you count, or flip the point, or you count diagonally. So like for B, it would be 1, 2 away, 1, 2 away. Let's see if we get the same thing as when we switch the X and the Y. So it would be +1, -3. +1, -3. Yep, it's the same. Awesome. And then for C, half and half. So it ends up there as C prime. And it gets perfectly reflected across, it's like a mirror across this. So our C prime would be 1, 0. Alright, and that is all if you are in regular geometry. If you're in advanced geometry, stick around. Alright, I've got my points written, so go ahead and do that. Now what we are going to do is we are going to take this line and reflect over this line. So we must first remember what y equals 2 is. So I know the y-axis is up and down, but if you have y equals 2, that means the only y value this line could ever exist on is 2. So it's going to be a horizontal line right there. So we are now going to reflect over this. So there's not really like this cool trick that you can change every point to. You kind of have to just look at the graph and reflect each point. So you start at the line of reflection, A goes up 2, so now we're going to make it go down 2. Start at the line, 1, 2 is up. Start at the line, 1, 2 is down. So it ends up A prime is at -3, 0. B prime and C prime. So B prime is 1 below, so now it's going to be 1 above. B prime is now -3, 3. C prime, 1 below, now it's 1 above. It's going to be 0. And not 1, 3. So we have 0, 1, 0, 3. All right, now that we've done this, we've got our A prime, B prime, C prime. We can see that our shape flipped over. But notice, as far as the changes go, was there a change in the x value for any of these points? Nope. Only the y value changed for every one of these. So For this, since it's y over 2, the y value will change. Okay? And last one, we have x equals 1. So it's going to be a vertical line. Since the only place this line can, the only x value this line can exist is at x equals 1. So I'm going to pause and write my points real quick. And alright. Well, we know that on the example above that our values changed for our not our x but our y. So I mean you can kind of deduce that the x value will change and the y will not. You know, if you want to go ahead and write your y values in, you can, because they're not changing. The x values will change, however. So we have a is 1, 2, 3, 4 to the left. Now it's going to be 1, 2, 3, 4 to the right. So it now becomes 4, 4. And then B is 4 to the left. Now it's going to be 4 to the right. C is 1 to the left. Now it's 1 to the right. And we have our triangle flipped over. And oops, you guys see my mistake here. It is now 5. So that's one easy thing. I was counting this like it was the y-axis, and it's not. It's the line we're reflecting over. So that's an easy mistake you can make. And then at C would become 2, 1. Right, so you're just, it's best to have the graph, count over the graph. Since it's 1 to the left, now it's 1 to the right. Since B was 4 to the left, now it becomes 4 to the right. Same thing for A. Alright, and that's it. Thanks, guys.